So at the Center for Exciton Science, one of our major aims is to try and understand how to make and use energy more efficiently from light. To do that, we like to make devices out of semiconductor materials, particular molecular semiconductor materials, which could be more efficient and more tunable than conventional semiconductors. We're really good at making new materials, turning those into devices, and understanding their properties that are going to be useful for turning them into technologies. Excitonic materials tend to act like semiconductors in a lot of their ways. So a lot of the times when we're thinking about excitonic materials, we're actually trying to use the ideas that exist in semiconductor physics and use those to turn these things into devices, to understand their optoelectronic properties, how they absorb and emit light, and these sorts of properties. The fit between the research we do at Exciton Science and the research that's discussed and talked about at ICPS is really great. There's a lot of work on organic electronics, on perovskite solar cells, there's a lot of work on fundamental photophysical properties of semiconductor materials, and they're the sorts of things that we do a lot of research of in our centre. We appreciate that the COVID situation around the world might make it challenging to get down here, but we really hope we can see you and meet up in person and have the sorts of interactions that we've been missing. If you'd like more information about the research we do in the Center for Exciton Science, feel free to read any of our papers. You can check us out at excitonscience.com. We're really looking forward to seeing everyone in Sydney in 2022.